This tiny thing is a charging circuit, and if you're new to electronics or plan to work on DIY projects, this circuit is a must know or have in your toolkit. With this tiny circuit, you can turn any device that uses dry batteries to using renewable energy. In this video, I'll be using this circuit to convert this Zoom microphone from using dry batteries to using a built-in rechargeable battery. Alright, let's go over to our workbench. Modifying this device was perfect because the battery terminals were already damaged due to alkaline corrosion. This device uses AAA batteries, but this modification can work for any device that uses 2-cell batteries. We first have to find a way to open the device. If you want to perform this kind of modification on something like a TV remote, the approach would be slightly different. Before applying the charging circuit, I had to make sure the device can work with a battery. So I directly soldered a battery to the PCBA. It's important to identify your negative and positive pads and solder them correctly. The device worked on the first try, even though the battery that I used for testing was slightly bigger than what I needed. I took it out for testing and yeah, the battery was too big and impractical to hold in the hands. The device has a micro USB port. You'd think it would be used for charging the device. But in this case, it's not designed to charge the batteries. It's only used for pass-through power and data transfer. The reason for this is them to be able to sell this device in different countries without the restriction of battery regulations and certification. The moment you connect the charger, the device has an internal chip that disconnects the batteries and continues using external power from the charger to power on the device. Which brings us back to our charging circuit. It consists of the following components. Main controller. This manages the incoming 5 volts and stops charging when the battery reaches its full capacity of 4.2 volts. Protection IC. This is a safety chip that monitors critical situations such as the battery is too low or prevents overcharging. Status LEDs for status, battery charging and battery low. LED resistor. These are current limiting resistors. Limit the current that goes to the LEDs. Filter capacitors, used for stabilizing the power. Program resistor, this sets the charging speed or current, 1 amp in this case. Now we have to reopen the device and remove our test battery, then take some measurements so that we can order or see if we have a battery that fits. We have about 2.1 millimeters and 4.8 millimeters space. I ordered the battery and comparing it to our test battery, we can see it's way smaller and will fit in perfectly. I got a 700 milliamp hour battery, which is good enough for a single day's recording on this device. The power consumption on this Zoom H1 mic is already good enough. It's important to identify our power input on the PCBA and find the best pads to tap our power from. I then identified the positive and negative by looking for V-bus, positive, and ground, negative, on the PCBA. I like taking an extra step further to make sure that the point where I plan to tap the power from is giving a full 5 volts, clean and not affected by surrounding components. After visually identifying V-bus and ground, I connected the charger and used my probes and multimeter to double check. I also want to make sure that wherever I will tap this charging circuit will not introduce noise when the device is operating. After identifying our clean 5 volts pads, it's time to connect our charging circuit. I cleaned up the old residue from the battery terminals, then solder the positive and negative output wires on the charging circuit. Solder the positive and negative input wires. Trim off any excess wires so that we avoid short circuits. At this point, I noticed I soldered the negative output wire on the battery pad, so it's a quick fix. Just desolder and solder it in the correct position. Connect the output wires from our charging circuit to the device. Positive input wire to V-bus and negative input wire to ground pad. Prepare the battery. Solder the battery positive wire to the B positive pad on the charging circuit. Notice the B positive is not marked. That's because there was not enough room for printing. Solder the battery negative wire to the B negative pad on the charging circuit. Trim any excess wires to avoid short circuits. Finally, we solder the charging circuit output wires to the device PCBA positive and negative respectively. Once we're done with the soldering, it's the moment of truth. Test if the device still works. The device does turn on, which is a good sign. Now let's confirm the charging works. Red LED turns on, we're good. Confirm there's no components overheating by touching. Temperature seems normal. Disconnect the charger, red LED turns off, we're good. Time to assemble. Let's make room for the battery and PCBA. I decided to cut this area of the plastic so that I have more room for the charging PCBA and the battery. This is the exciting part. It's time to put everything inside, and if you have OCD, please skip this part as I'm not doing any cable management for this one. Then one last time, turn the device on to confirm if it works after cramming everything inside. Charging works, perfect. If we check on the back side, we can see the red LED indicator confirming that the battery is charging. I decided to apply some insulation to prevent the battery from getting punctured. The battery fits perfectly. I'm happy about this. And the back cover closes perfectly. And we're done. The device can charge and no more buying battery cells. Now, I have to mention, this is a simple version of this circuit. There's definitely more power efficient circuits that are available and designed, readily available for you to buy on the market. But for a simple proof of concept or prototyping, this circuit works just fine. If you're interested in seeing more videos like this, hit the subscribe button. If you watched this video till the end, make sure you hit the like button and share it with your friends. Thanks for watching, and I'll see you on our next adventure.